This is Nikhil. I am working as an application engineer in Tektronix. This demonstration focuses on record and playback system. So we have here AWG5204 arbitrary waveform generator, which we're going to use it for modulation generator. And I have a portable USB RF analyzer, which is RSA306, with me for doing analysis, and this can also do streaming of IQ data over a computer. So that's what we're going to do it. So let's get started with this. I have right over here AWG screen with me. So once you will land up on the AWG, you will see this screen. I'm just going to set it up to go into the waveform plugins, and since RF generic is already selected, and here we can set it up the desired modulation for SDR, record and playback, which you want to do. So let's get started. I'm setting up center frequencies as it is, like 1 gigahertz, and power level let's set to 0 dBm. Here is a tab where we can set it up the modulation parameters. So as you can see, this is the base pattern where we can see all PRBS sequences which are there. I'm selecting PRBS 7, and from this drop down you can select type of modulation you are going to use it. So I have here which is QPSK. We can provide the data rate, so I'm putting it to the 10 mega symbols. So for QPSK, since we are using a 2 bits, so your data rate for this is going to be a 20 Mbps. After this, once you're done with the data rate and modulation settings, you can go in a pulse shaping of INQ data, which is there. So I'm using a raised cosine, or you can use even a root raised cosine or rectangular filtering. So we are using a raised cosine with filter roll-off of 0.35, and we are done with the settings of signal generation along with the carrier. So this is going to be your IQ data, which is superimposed on carrier frequency, which is there at 1 gigahertz. What I'm going to do is I'm going to go and assign it to the particular channel, which is channel number 1, where I have connected right RSA, and I'm going to just compile the waveform and hit onto this. And as you can see, is the waveform has started playing up. I can just go in a home screen, and this you can see the time domain waveform. I can change the unit to dBm so that you can easily see this. Let me set to the right what we need, 0 dBm, and just change it to screen to RSA, which is right connected on my laptop. So now, as you can see here, the spectrum analyzer is already set up, but let me just reset and set it up for, let's say, 1 gigahertz. This is where you can easily set up the span, which is 40 megahertz. Reference level, I'm putting slightly above, which is our power level, 5 dBm. Or how you can judge is, you can just turn on the time overview window, and from here you can set it up the right reference level which is needed for you to analyze the signal. Once done, I can go in GPD mode and turn on the constellation diagram, symbol table, and signal quality parameters. So this will allow me to set up the demod parameters for modulations which we are going to analyze. So rightly we have selected the QPSK. Here I have to select the symbol rate which has been provided. So we are setting it up to 10 mega symbols. So now you can see it's quite shaped up, but still there are a lot of points which is going outside of constellation points. That is just because of filtering. So once I can apply, say, raised cosine filtering, and filter alpha, what we were having is 0.35, and we can see nice parameters right over here, which is around 1% or less than a percent over here. So this is just to show the demodulation part of it, where we are seeing the signal quality of it. What I'm going to do is, now we are going to record this signal. So we have a data view PC software in which we can do a recording part of it. So the recording can be done from the data which is streaming out from the USB RF analyzers. So I can come here to the RSA view, and as you can see, it's like connecting onto the right. So we have this, we can set it up the same parameter what we have set up over there. So reference level, we are setting up 8 dBm. Let me put a little bit more, say 10. Right, and viewing is from 15. So I can see the same DPX view of it, and from here I can set it up what I want to record the data for. So I can give the name of the file, saying I have 1 gigahertz QPSK modulated data, and the span you want to record for, as well as the timing. So the timing we are specifying right now is 10 milliseconds. So that's a long burst which we are going to generate. We are going to record it, and once you're done with all settings, you can just hit this start capture, and you will see the progress right on the below bar. So as you can see, it's just recorded. Now what we can do is, since this is recorded in multiple format, which XDAT is just called normal data which can be done, or we can open up into the MATLAB and other processing softwares, or you can use it into the TIQ file with which signal generator can easily understand those data. So here I'm giving the name as same as in TIQ, say 1 gigahertz UPSK, and just make sure that you have selected the TIQ and just say save, and I'm recapturing the data file. Now I can come over here, and I can go into the data view files, and as you can see, there are the data which we have recorded is right over here. I'm going to copy the data, and we are just going to play back the same. And if you have a LAN connected right over here, then you don't need to do this manual transfer, but you can control AWG from Source Express, and from there only you can directly recall this file and can play out the waveform. Right, so just stopping the file, and let's go back, and here is a capture playback tool where you can add up the signal. So here you can say add signals which is recorded, whether you have a separate INQ files, or you will have IQ file together, which is TIQ, and we're just going to browse the file from 10 megahertz, and I'll say open and just add the signal. So if I'll open up this, it will show you how much length of the waveform is and what the sample rate on which we are capturing I and Q. Once done, you can put the desired frequency. No need to be a same as it is like what we have generated from here. It can be any other frequency, So we are keeping it same for simplicity, and I'm just compiling the waveform and assigning and playing on channel number 1. And once you're done, I'll hit the compile button, let it go through the channel number 1, and I'm just going to switch again to spectrum analyzer part. So as 1 GHz is rightly tuned, and we're going to do the same procedure back again, setting up the reference. Then we'll go in a general purpose demodulation, and we're trying to do the same settings what we have applied over there. You can put it on the raised cosine, and filter alpha is set to the 0.35, and again you can see the constellation is right what we have got earlier. And so that's what this demonstration is about. You can generate the signal, we have recorded, and we are just capturing back and playing onto the playing back through the AWG on, and again doing the analysis. Thank you for watching.